If you're getting into game dev, you need to create a Pong clone because it's the perfect beginner project with how simple the rule set is. And in this tutorial, I'm going to show you exactly how to do that and make it even cooler by adding fancy CSS animations, a computer AI, and also a scaling difficulty. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. And in this video, we're going to create this really interesting Pong clone here. So to get started, all that we need to do is have an empty project open, and we need to create an index HTML file. So let's create an index HTML. We're also going to create a styles.css file, and we're going to create a script.js where all of our JavaScript logic is going to rely. And what we can do is we can just open up this index HTML after we create all the content by hitting !enter. That's going to create this boilerplate code. And then we can open that with live server. So we can just come over here, save this, right click, open with live server, and that's going to open up on the right hand side of our screen. And this is going to be just a blank HTML page. Now to get started, I want to put all the HTML that we're going to use, then I'm going to work on the CSS, and then finally work on the logic for the game. Now in our HTML, we need a few different sections. We're going to have a score section where we're going to put all the score. So this section is going to have essentially a player score, and that player score is going to be 0. And it's also going to have a computer score, which is going to be 0 as well. Then below that, we're going to have a ball. And this ball, we're going to give both an ID of ball and a class of ball, as you can see here. And the reason I'm separating the IDs and the classes is so I can use the classes in CSS and the IDs in JavaScript. It just makes the code a little bit cleaner and easier to work with. Then we're going to have essentially the same thing. We're going to have some paddles. We're going to have a paddle for the left player, and this is going to be our player paddle since they're going to be on the left. And we're going to copy that down for a paddle on the right-hand side, and this is going to be for our computer player. Right here, this is all the HTML we need. It's really quite simple because Pong doesn't have very many moving parts, but the styles and the logic behind it is much more complex. So let's import our style sheet by just coming in here saying link, and we want to say styles.css for our style sheet. And while we're at it, let's do our script tag as well, and we'll give this script.js. We're also going to set here a type equal to module. Now, if you're unfamiliar with what this type module does, I have an entire tutorial covering it. I'll link in the cards and description for you, but essentially it allows us to use modules in our code. Now let's move over to our style CSS and start styling everything. The first thing I like to do in every style sheet that I work on is I like to select everything, including all the before and after elements. And I like to set my box sizing to be a border box. This just makes sizing my widths and heights so much easier. Then I also almost always set the margin on my body to 0. And again, that just makes working with this so much easier. Now the next thing I want to do is actually start working on the paddles and background colors. So let's come in here and we're going to say for now, just a background color of black is going to be the background for our board. And since that's a little harsh, let's just do like 333. So it's not quite as harsh of a black color. And then what I want to do is I want to select my paddles. And the paddle here is where we're going to have these things on the side of our screen, one on the left and one on the right. So in order to style these, we can do like paddle.left. That'll select our left paddle. And paddle.right will select our right paddle. And this main paddle class is going to be the styles for all of our paddles. So first, I want to set the position to absolute so I can position these absolutely. And our paddle on the left, I just want to have a left position here, which is going to be 1 VW. So it's going to be 1% of the screen away from the left-hand side. And same thing down here with our paddle right, I'm going to use right is 1 VW, so it's 1% of the screen width away from the right-hand side. Now, if you're unfamiliar with like VW and VH and so on units, I have an entire video covering them. I'll link in the cards and description for you. Now, the next thing I want to do is I want to specify the background color. For now, I'm just going to set this to white, and I'm going to come in here with a width of 1 VH, and I'm going to come in here with a height of 10 VH. If we save, you can see we now have our paddles on the left and right of our screen. And the reason I'm using VH for the width and height is because I want the paddle to always be 10% of the height of my screen to make sure that the game is always fair no matter what size screen we play on. If I set this to like 100 pixels and you made your screen 100 pixels tall, the paddle would cover the entire screen. Obviously that wouldn't work. So now no matter what size my screen is, it's always 10% of the height. And I used 1 VH on the width. And that way the paddle is always 10 times higher than it is wide. It just makes it look a little better because if I set this to 1 VW, the paddle just doesn't quite look good on all screen sizes, while 1 VH means it'll look a little bit better. And the next thing I want to do is I want to specify the top position. And the top position here, I want to set to 50 VH, just like that. And I'll make sure I put a semicolon here, so that way it's going to be positioned in the center. But you'll notice the top of it is 50% of the way down the screen. I want the center to be 50% of the way down the screen. So we can just do a simple transform, translate. And what we want to do is translate in the Y direction, negative 50%. That moves it back up half of its own height. That way it's dead center in our screen, which looks really good. Now this top position of 50 VH is something that we're going to set in our JavaScript. So I want to make that a CSS variable. We're going to call this position. I'm going to set this here to 50. And we're going to be setting this in our JavaScript. So down here, what I need to do is I need to use that variable, which is position, and I need to convert that to a VH value. To do that, I can just use calc, and I can say times 1 VH, just like that. When I save, we get the exact same result. But the important thing is I can actually change this position in my JavaScript code incredibly easily, and it's going to update this top position for us. Now, the next thing I want to do is to work on my colors a little bit, because right now I have it hard-coded to this like black and white color scheme, and instead I want to make these colors dynamic so I can change them in JavaScript. So let's just come up here and select our root element where we can put CSS variables that go across our entire application. I want to create a few different variables. The first variable I want to select here is called hue. I'm going to set that to 200, and I also want to select a saturation, which I'm going to set to 50%. And these values we're going to be using in an HSL color format. If you're unfamiliar with that format, I have an entire video covering it. I'll link in the cards and description for you. But essentially, if we just create a foreground color here, so we'll say foreground color, we can set it to HSL. We can get our hue portion from that variable hue. We can come in here and we can get our saturation portion from that saturation variable. And then we can specify our lightness value, which in our case is just going to be 75%, because we want our foreground color to be a very light color. Now let's just make sure that we close off all of these. This just has an extra var here. There we go. So now our foreground color is set. So down here, instead of using the color of white, we can specify this as our foreground color. Now when we save, you can see we kind of have that light blue color. We can do the same thing with our background color. So we can say background color here, and I want the same hue and saturation, but the lightness is going to be 20%. So it's going to be much darker. And if I set this to our background color and save, you can now see we kind of get this dark blue color. And the great thing is we can change our hue. For example, I can change it to 100. Now we get green. 0 is going to give us red. Do 300 to get this like purpley color. Or I could change our saturation to like 0. And now you can see we kind of gone back to that black and white style. So I really like this because it allows you to actually really easily change the look and feel of your site. And we're going to be modifying this in our JavaScript. So as you play the game, it's going to cycle through the hues and just give you a more pleasing experience by being all these different colors. And the next thing that we can focus on styling is going to be the ball. And our ball is actually not that much different from the paddle, to be honest. They share a lot of the same characteristics. I'm just going to copy all of this down here for now. So instead of having a position, we're going to have an X and a Y. So I'm going to say X here and Y, and both those by default are going to start at 50 because that's going to be the very center. And then instead of having a top here, we're going to have this be our left, and our left position is going to be X. And we're going to do here our top position, which is going to be our Y. And our left is going to scale off of view width units, while our top is scaling off of VH units. Now, if we come in here with a width and height, which in our case, we're going to do 2.5 VH for both of those, that way it gives us a perfect circle, you can see we have that square right in the middle of our screen. The only thing we have left to do is fix this translate. This should say translate, and we want it to be negative 50% in both the X and Y direction to make sure it's perfectly dead center in our screen. So that right there gives us the ball pretty much exactly how we want it. The only thing left just to set a border radius, and we want to set that to 50% so we get a circle instead of a square. Now the final thing we have to work on is our score, and we want that to be in the top center of our screen. So let's come down here, we're going to select our score, and this is right here the thing that wraps both of our different individual scores. So we want this to be a display here of flex, and we want to justify our content in the center, and we're going to change the font weight here, be bold. We're also going to change the font size to be 7VH. Again, we're going to make it just scale with the screen size. So as you can see, we right now have our text in the very center. We can also specify the color of this text, and our color is just going to be that nice foreground color. So as we change the color of our paddles and everything, the text is going to change along with it. It's going to look really nice. Now the next thing I need to do is style the actual scores themselves. So I can say score. I want to get every single direct child. So this is just selecting all the things inside of score. I can change them to have a flex grow of 1 and a flex basis of 0. What this is going to do is it's going to make sure that exactly half of the screen is taken up by one score and the other half of the screen is taken up by the other score. You'll notice now this score is all the way on the left side of our screen. What I want to do is I want to select the first child, so pretty much get the first score, and I want to set the text alignment to the right side of my screen. And that's just going to make sure it mashes back up onto the right. So these are both side by side, and they always take up 50% of the screen, no matter how much text is in one. So if this is a really large number, you can see it always stays on the left-hand side of our screen, while if this is a large number, it always stays on the right-hand side of our screen. Set those back to 0 and 0, and we can go into our styles again to finish this off. So inside of our score here, let's add a little bit of padding. So we're going to do 0 on the top and bottom and 2 VH between them. So it gives a little bit of space between the elements, which looks good. And our margin, we're going to set 1 VH on the top and bottom and 0 on the left and right. That way it just spaces out from the top of our screen and the bottom of our screen a little bit. And then finally, I'm going to set the opacity to 0.5 because I just don't want this to be quite as in your face as the rest of the game since it's not as important. Now, lastly, I want a line to show up between them. So I can just put a simple border on the right-hand side of our first child, which is going to be 0.5 VH wide, so pretty thin. I'll make it solid, and I'm going to make it that same foreground color. So now if I save, you can see we have a border between them, so we can easily distinguish which score is which. With that, that's all of our styles and all of our HTML done, and we can finally move on to the fun part, which is the JavaScript. Now, to get started with this game, essentially we have a few things we need to understand. The first thing is that our game is going to run inside of something called an update loop. So every single frame that passes, we're going to be calling a function, and that function is going to update the positions and the logic of all the pieces of our game. So for example, the computer AI is going to move the paddle, the ball is going to move in the current direction it's going, and we can move our paddle with our mouse as well. This is going to update all of the positions and paint everything on the screen exactly where it needs to go inside of the update loop. Then the next important thing to note is we're going to break out everything in our game into separate classes just to make them easier to work with. So for example, our ball, we're going to put in its own file called ball.js, and we're just going to set an export default of our class, which we're going to call ball. And inside the constructor, we're just going to pass in the element that corresponds to our ball. So we can say this.ball element equals our ball element. So this element right here for our ball is just being passed into this ball class, so we can actually use it and interact with it. So to do that inside of our script here, we can just come to the very top, get rid of this, we don't need it. We can say import ball, this is the default export, from, and I want to get it from /ball.js. Then I can say that our ball is equal to a new ball, and I just want to pass in that ball element, which we gave an ID of ball. So this is selecting the ball HTML element and creating a new class for that ball, and now we have access to it here. Then we can use that inside of our update loop if we want. What we can do is we can create a function called update, and this update loop is going to take in a time variable for how much time has passed since the start of our program. And then in order to call this, we can say window.requestAnimationFrame, and we're going to put in that update function. Now, many tutorials that you see will probably have like a set interval here where it calls update every like 10 milliseconds or something. This is a bad practice. And the reason for that is because set interval is not really super accurate. It may not always run every 10 milliseconds, so you kind of have some problems there. And also, it's going to run in between frames. With request animation frame, what happens is every time that you can change what's on the screen, this function is going to be called. So JavaScript is smart enough to say, hey, you can't change anything on the screen, so don't even bother running code. But now as soon as you can run something on the screen, it calls this function for us. And as long as we keep calling window.requestAnimationFrame, it's going to infinitely loop. So right here, we've created an infinite loop, which just calls update every single time that something on our screen is allowed to change. So every frame, it's going to call this function for us. And all we need to do is set this up, and now we have that update loop. I can say console.log time, and now if I come over here and I inspect our page, go over to our console, you can see it's printing out that time, and it's just constantly getting bigger. As you can see, it's incrementing by about 5, 10 milliseconds at a time. It's a very small amount of time between each render of our screen. Now what I need to do is I need to take this time that gets passed in and convert it to something called a delta, so we can determine how much time has passed from the previous frame to the new frame. To do that is actually quite simple. I can just say const delta is equal to time minus, and I need to get the last time. So let's create a variable called last time. By default, it's going to be nothing. And then every single render, we're going to set our last time equal to our current time. So now what happened here is every single time we call update, we're taking our last time and we're subtracting our time from that last time to get our delta. And then we're setting our current time to the last time, and then it'll repeat. But the first time we call update, last time is null. We don't have a last time. We need to check for that. So if last time is not equal to null, then we're going to do all of our important code. So here we're doing all of our important code for updating everything. And then what we want to do is come down here and we're going to set our last time in our window.requestAnimationFrame. So inside of here, we're going to do our update code. And we're only doing our update code if we have a last time. Because if we don't have a last time, then that means that we don't have anything to compare to get our delta. So the first time we call update, nothing in here runs. We just set our last time and call it again. The second time it runs, we have a last time, so then we can use this delta and so on. So now if we just console.log our delta, and I inspect our page over here, go to our console, you can see we get our delta being logged out, and it's around 7 milliseconds every single time. And you can see there's a little bit of fluctuation, which is okay. Now inside of here where we're doing our update code, what I want to do is I want to take our ball, I want to call the update function on it, and I'm going to pass in that delta. This update function is a function we're going to create, and we're passing in the delta into this function. And the reason we're passing that delta in is because, as you saw, that delta fluctuated. Sometimes it was like 6.9 milliseconds, sometimes it was like 7.1. It fluctuated a little bit. So it's important to use that delta to make sure all of our movements in our game are based on that. Because if, for example, we have a big frame drop and the time between frames is like 50 milliseconds, we want to make sure we take that into account when we're performing our calculations. So inside of our ball, let's create an update function, which takes in a delta. Now, before we get writing this function, we need to think about what are we updating with our ball. Well, we know our ball has a position. It's going to have an X and Y position, and it's also going to have some kind of velocity, which it is moving, and it's also going to have a direction which it's moving. So in our update, what we want to do is we want to take that velocity and the direction and add that onto our current position, and then do all the calculations to see if it's bouncing off a wall or bouncing off a paddle. So inside of our update, we need to first get all this information. So we need to create some helper functions so we can do that. So let's create a helper function for getting our X variable. And this is just going to return to us a value, which is X. And if you remember in our styles, way up here, we set our X right here to 50, and it's that CSS property. Well, to get that CSS property, what we need to do is we need to call getComputedStyle, and we pass it in our ball element. And then we want to call the getProperty value, and pass it in the name of that CSS variable, which is just --x. Then what we want to do is we want to parse this as a float. So essentially what we've done is we've taken the value from our CSS right here of 50, and we've converted that into a JavaScript number that we can use. I'm also going to create a setter for our X, and the setter here is going to be ballelim.style.set property, and it's going to be that X property, and we're going to set it to a value which gets passed into setX. And these getters and setters here are really nice in that you can just say like this.x equals 5, and it's going to call this setX function, pass in 5, and do all of this code for us. So it's going to set our position to 5. And now if I save, you can see our ball has moved to have an X position of 5 because we're calling update repeatedly, and we're just setting X to 5 inside that update. So we now have essentially called our update, and we can set our X position. Let's just copy this so we can set our Y position as well. We're going to come down here with Y, and just change these also to be Y. So now I can say this.x is 5, and let's say that this.y is 15. So now when I save, you can see our ball is up here in the top left corner, 5% away from the left and 15% away from the top. So now we have our X and Y position taken care of, but we still need to worry about our velocity and the direction that we're traveling in. And this is something we probably want to set up when we create our ball. So I'm going to create a nice helper function called reset. And this reset function is going to allow us to set all those properties. So when we create a ball, we're going to make sure we call that reset function. And inside of here, I just want to take our X and I want to set it to 50. I want to take our Y, I want to set it to 50 as well. So I'm just going to default these to those initial values in the middle of the screen. And then what I want to do is I want to find out what our direction is. And this direction is a little bit complex. So our direction is going to be essentially an X and a Y coordinate. So let's just say like 0.75 and Y is going to be like 0.5. Let's just pretend that these are the values for X and Y. And that's what our direction is going to look like. So to visualize this, let's take a look at this diagram here. We have a Y direction and we have an X direction. So our X value of 0.75 represents this X direction here, and Y represents the 0.5 going upwards. And then we have this A line. This A line is going to be the actual direction that our ball is traveling, which is essentially a combination of our X and our Y. But the really important thing we need to make sure we do is we need to make sure the length of A here is 1. So whenever we calculate A, the length is always going to be 1. The reason that's important is because this is giving us something called a unit vector. And then we can multiply our unit vector, which is 1, by our velocity. So let's say our velocity is 20, and it's going to mean that we're going to move 20 units in the direction of A. And the reason that we need this to be a unit vector is because if our vector here for A was like 30 units long, well then when we multiplied 30 times 20, we would be moving 600 units in the same direction. So by having a unit vector for our direction, it means that our velocity is the only thing that determines how fast we go, and our direction only determines which direction we're going and not the actual velocity. That may sound a little bit confusing, but as we get to the actual code, I'll explain it a little bit more depth and show you exactly what I'm talking about. So in order to calculate our direction, what we need to do is we need to essentially create a value for our X and our Y. And I'm actually going to do this inside of a while loop, which you'll see why in just a second. For now, we're just going to set this to while true, but I'm going to actually put the code for while inside of here. So what I want to do is I wanted to get the heading, essentially where are we heading in a rotation, so like 0 to 360 degrees. And this heading variable, I want to make sure that this heading is going to be set in terms of radians. I'm going to try to get a random number between, I want to get a random number between 0 and 2 pi. And that's because 2 pi is essentially the equivalent of 360 degrees. We'll say math.pi. So now this random number between will give us a random number from 0 to 360 degrees, but it gives it to us in radians. And with radians, we can use cosine and sine to actually determine the x and the y direction. So what we can do here is we can say this dot direction is equal to, make sure I spelled direction correctly, an x, where x is the cosine of our heading, and the y is going to be the sine of our heading. And now what we've done here essentially is we've created a random value between 0 and 2 pi to determine our direction. And then we say taken that direction and we've converted it to an x and a y position. And this is going to be a unit vector for those positions. It's going to give us an x direction, for example, 0.75, that says we move 0.75 units to the right and we're moving 0.5 units up. And when you combine those together, we're going to get a unit vector that points 1 in the direction of the x and the y combined together. Confusing, I know, but you'll see how it works once we get the code actually running. Now, the reason I have a while loop here is because the game isn't very fun if the ball always moves up and down and not very far left or right. So I want to make sure our x direction is at least big enough or small enough that it's going to move far enough to the left and right to make the game enjoyable. So I'm just going to come in here. I'm going to say if this dot direction dot x is less than or equal to 0.2, or the direction is greater than or equal to 0.9, that just means that the game is not going to work very fun because it's going to be mostly up and down and not very far side to side. Make sure this is .x. And the reason we're doing a check for both less than 0.2 and greater than 0.9 is because if it's greater than 0.9, it means the ball moves almost side to side completely without very much up and down motion. And less than 0.2 means it's moving almost entirely up and down, not very far left to right. And since we can get negative numbers, I want to make sure we absolute value this. So by doing this, we're saying, hey, is the absolute value going to be less than or equal to 0.2? Because sometimes we'll have a negative value like negative 0.8, and that's going to be fine. So we want to make sure we do the absolute value for both of these. So math.absolute value of this one as well. Now, if we just set our x here to like a default of 0, that's going to make sure that our while statement here is true. And then we're going to come into here and we're going to do all those checks. So now if I save this and I just console.log this.direction, and I come over here, you can see that we get a random direction, but of course, random number between is not defined. So let's create that function ourselves. We'll say random number between a minimum and a maximum. And this function is pretty simple. We're just going to take a math.random multiplied by our maximum minus our minimum. Oops. Just like that. And then we're going to add our minimum on the end. So essentially what this does, it gives us a random number between 0 and 1. We're using this max minus min trick to make sure that it's going to scale this value to be within our range and then add the minimum on just so it's always making sure the minimum is the lowest number we can get. Now you can see we get an x direction of 0.6 and a y direction of negative 0.7. And if we just refresh our page, you can see we get completely random directions again and again and again, and every single time we're getting random directions. So now the very last thing we need to do is just specify our velocity. So we can say this dot velocity is going to be equal to some initial velocity value. I'm going to make this a constant variable, which we're going to define way at the top of our file. So we'll say const initial velocity, and we're going to set this to 0.025. You can mess around with this number all you want to try to tweak it to find the exact value you want, but this is a value that I think works pretty well as a starting value. It's slow enough, but fast enough it's not too boring. So now that we finally have all of our values set, we can actually do our update like we want to. So the very first thing I want to do is I want to take our x value and I want to add it the direction we're going. So I'm going to say plus equals. So this is going to add to our x value. And what I do is take our direction in the x, and I want to multiply that by our velocity. And right here, what we've done is we essentially said, hey, take the direction we're going in the x direction and multiply it by our velocity, and we're going to move the x position that much. But the important thing to note is we make sure that we multiply our delta onto the end of this. That's because, again, if we have long delays in between animations of our frames, that's going to be a large delta, so we want to make sure our ball moves a large distance if there's a large pause between frames. And if there's a small pause between frames, the delta is going to be small, so the ball moves in a smaller increment. I want to do the same thing for our y down here. I'm going to change this to our direction in the y direction. Now, if I save, you can notice our ball is moving, but of course it doesn't quite look right. That's because I need this to be plus equal for our y. Now, if I save, you can see our ball is moving down to the bottom right. If I refresh, you can see our ball is moving down to the bottom left. It's moving up this time. It's moving to the right this time. As you can see, every single time it moves in a random direction. One thing you'll notice though is when it goes off the page, we get a scroll bar. Fix this, we can go to our body and we can set our overflow to hidden. And now when I save, you notice that even though it's outside the bounds of our screen, we don't get those scroll bars anymore. Now the next thing to do is to make it so it bounces off the top and bottoms of our screen. So what we want to do is we want to create a simple function called rect And this function is going to get as the position of our ball. So we can just say return this dot ball element dot get bounding client rect. And then down inside of our update, we can just say const rect is equal to this dot rect. Then what I can do is I can just put a simple if check. I can say, hey, if the bottom of our rectangle is greater or equal to our window dot inner height, then that means that we've gone past the bottom of our screen. Or if our rect dot top is less than or equal to 0, that means we've gone off the top of our screen. So what I can do here is I can say, hey, this dot direction dot y is going to be multiplied by -1. So all we're doing is flipping the y direction. So when we hit the top of the screen, instead move downwards, and when we hit the bottom, instead move upwards. Now if I save this, we get a ball that moves upwards. So let's just refresh till we get one that moves mostly up or down. You can see once it hits the top, it'll now bounce and change its direction. That's exactly what we want. We can also do the same thing so it bounces off the left and right side of our screen. The only reason that we're doing this right now is so that we actually can test to make sure everything's working. Eventually, we're going to make it so this only bounces off the paddles and not the screen. So if our right side is greater than or equal to our inner width, or our left is less than or equal to 0, we're going to multiply our y by x by -1. Now, no matter what wall we hit, we should be bouncing off of it. But you notice the ball is kind of slow, and it always stays slow. We want this to speed up as time goes on. So what we can do is we can take our velocity, and we can multiply our velocity by some kind of increasing value. So we can say velocity increase, and of course, make sure we include the delta as well so that it scales with the frame times. And then up here, we can set that value. We want this to be a very small value because this is going to be adding in every single time. I want to make sure down here, I do a plus equal instead of a minus, or multiply equal. There we go. We can do velocity increase. And this value, like I said, very, very small. We're going to do 0.00001. So now when I save, you notice the ball starts out slow, but as you can see, over time, it starts to get faster and faster. And it starts to ramp up pretty quickly, even though our value is really small. And then eventually it's going to become so fast that one of the players is going to lose, either the computer or you. And then hopefully once someone loses, we're going to reset the ball back in the center, move it back down to the slower speed using this reset function and have it move in a random direction. But as you can see, it's continually getting faster and faster and faster and faster. Now what we can do is we can go back to our script, and for now I'm just going to comment out that ball update so we don't have it flying around all over the screen. What I want to do is I want to focus on the paddle portions of the game instead. We're going to first focus on the player paddle, and then we're going to work on the computer paddle. So let me get our player paddle. We could say player paddle is going to be equal to a new paddle. This is just going to be document.getElementById, and this is player paddle. I'm going to do the exact same thing for our computer paddle. There we go, computer paddle, and we just need to create this paddle class. So let me just make sure we import it, and then we can create a paddle class, paddle.js, export default class, paddle, and it's going to have a constructor that takes in our paddle element. We could just say this dot paddle element equals paddle element. There we go. Now we have a player paddle and a computer paddle that we can use. And for our player paddle, it's going to be very easy to update because we don't even need to use an update function since we're just going to make the Y position of our paddle the same as our mouse. So way down here, we can say document.add event listener on mouse move. We're going to get that event object. This event object has a Y property. So all I want to do is I want to take our paddle for our player, so player paddle. I want to set the position equal to e.y. Simple as that. But this position in our CSS, if we go over to it, you can see our position here is using percentages. So it's 50% of our screen, 50 VH, for example. Here, this is a pixel value, so we need to convert this to a percentage by dividing it by our window.innerHeight and then multiplying by 100. So this is going to convert it to a value between 0 and 1, and this will give us a value between 0 and 100 for our position. Now let's make it so we can set the position of our paddle by using a getter and a setter for our position. Set position, there we go. Here, we're going to do position, and here it's going to pass in a value. This is going to work exactly the same as our ball. So up here, we can just copy the get for our position here. And this, instead of saying X, is going to say position. And then we can copy the set. Again, it's going to be the exact same thing, but instead of X, it's going to be position. And instead of ball element, we're using our paddle element. So now if we save and I move my mouse, you can see that the position of our paddle is exactly the same as the position of our mouse. And no matter where I move it, my paddle is falling. The reason it's doing that is because right here, we're just setting our position paddle equal to wherever our mouse moves. We didn't even need to worry about the update code at all for our paddle, which is really nice. But for our computer generated paddle, we're going to need an update for that. So for our computer paddle, we're going to come in here and we're going to call that update function. And of course, we're going to pass in the delta. And also, we're going to need to pass in the Y position of our ball because the paddle needs to know where the ball is so it can move to that position. So we're passing in the delta and the Y position of our ball. Then inside of the paddle class, we can set that update function. Inside of here, all we need to do is just make it so our paddle follows wherever the ball is on the screen. So we could make it super simple by just saying, here, this is going to be our ball height. We could just say that the paddle position is going to be equal to ball height. And that would mean that essentially the paddle is going to move to exactly where the ball is instantaneously. But then you would never be able to win. The computer would be impossible to beat. So instead what I want to do is I want to make it so that the computer has a maximum speed. I'm going to set to a variable called speed. And this speed variable we'll just say is 0.02. And then what I want to do is I want to say, hey, our position is going to be incremented by an amount, which is going to be our speed times the delta. And then what I want to do to determine if we're going to move up or down is I just take our ball height minus our current position. So if the ball is above our current position, we move upward. And if our ball is below our current position, we're going to move downward. So this is going to just give us a negative or a positive number. Also, this number is going to be larger when our paddle is further away from the ball so that the computer can move faster when it is further away from the ball. So now, if we save this, you're going to notice nothing at all changes. But if we go over to our script and make it so the ball starts moving, we should hopefully see that the computer paddle is following the ball exactly, which is what we want. But eventually, once the ball starts to move too fast, the computer is no longer going to be able to keep up, and then the player will be able to score. So that's kind of the idea behind this AI. It's a very simple AI. You can make it more complex, less complex, whatever you want, but I kind of like the AI how it is. Now let's turn off the ball update again so we don't have that flying all over the screen. Instead, what I want to do is I want to create a setup position for our paddle so it always resets to the center of our screen. To do that, we're just going to create a simple reset function. Reset. And this reset function is just going to take our position and set it to 50. And then when we create our paddle, we're just going to say this.reset. There we go. So now we've reset our paddle in the center every single time we call that reset function. And in order to actually do this reset, what we need to do is to determine if we've lost the game, essentially if the ball has gone off the side of the screen. So in our script, let's actually worry about that. So here inside of our update, we want to say if, we'll say is lose, then what we want to do is we want to run some code, and we can create that function is lose. And this is lose function is actually really simple. In our ball, you remember down here where we calculated, hey, is the ball outside of bounds? Well, let's just copy that code. We're going to paste it inside of here. So if our ball is outside of bounds, then we have lost. This is our lose code right here. So really all I want to do is I just want to return this as a variable. So I can say return right here, and I just want to get the rect for our ball, which is equal to ball.rect. So this is just saying, hey, is our ball out of bounds on the right or left hand side? If so, we have lost. So inside of here, I can just say console.log lose. And then in our ball, we can just make it so it doesn't rebound. We'll just comment out this code for now. And if we go into our script and we update our ball, as soon as it goes out of bounds, we should see in our console, it prints out lose as our text. And it's just continually printing out because our ball is continually out of bounds. So what we need to do instead is now handle when our ball is out of bounds. Let's again just turn off that ball update for now. And inside of our is lose, we want to call a handle lose function. Call a function called handle lose. And this function is going to do everything for resetting our game back to where it was before. We'll say handle lose. Make sure I spell that correctly. And what I want to do here is I want to take my ball. I want to reset it into the center of the screen. I want to take the computer paddle. I want to reset that back into the center of the screen as well. And then I want to increment the score. So we could say our rect is equal to our ball.rect. And then I want to say, hey, if we went off the right side of the screen, the player actually scored. So if rect.right is greater than or equal to window.inner width, there we go. Then that means the player has scored. So I'm going to take the player score element, which is a variable we're going to create. Just say const player score element is document.get element by ID. And this is just player score. That's what we called it. I'll do the same thing for our computer score. So we want to get our player score element. I want to get the text content inside of it. And what I want to do is I want to set this equal to essentially one more than the text that's currently in it. I'm going to parse an integer version of the text that's in there right now. The player score element dot text content add 1. And that's because by default, the text is set to 0. And then the other thing we need to do is just check to see if the computer one, so we can just use else here instead. And if the computer one, all we need to do is just copy this line down and use the computer score instead of the player score. I'm going to take the computer score and increment it by 1. So now if I save and I make it so our ball updates, and I let the ball go off the right-hand side of the screen or the left hand, let's just let it go off the left hand because that's easier to just lose. And actually it went off the right-hand side because we don't have our paddles working yet, but you can see the score is incrementing properly. When it falls off the right-hand side, the score for me goes up by 1. If it falls off the left-hand side, the score for the computer goes up by 1. That's working as expected, but we're not bouncing off the paddles. Let's work on that next. Again, I'm just going to comment this out so it's not moving all over the place. And we can go into our ball and we want to be able to check, hey, did we bounce off the paddles here? If so, then change our direction. We need to pass in our paddle recs. This is the rectangles for our paddles. Now, in order to get this inside of our paddle, we need to create a rect function. And this rect function is just going to return this dot paddle element at get bounding client rect. There we go. That's going to be our rectangle. Then in our script, what we can do is we can just pass in, we can pass in our rectangles. So we can say player paddle dot rect, and we can say computer paddle dot rect. That's going to be both of our rectangles passed into our ball. Then inside of our update here, for our if check, we want to check to see if any of our paddle rectangles had a collision. So we can just say paddle recs.sum. We're going to take that rect and we're going to call an isCollision function, passing in our recs for both the paddle and our actual ball. So this function just loops through all of our different paddle rectangles. And if any of them return true for this isCollision function, it's going to return true for the entire thing. Let's create that function, isCollision. This function is pretty simple. We're going to take in rect1 and rect2. All we're going to do here is just do a simple return where we're taking our rect1, checking that the left side of it is less than or equal to the right side of our rect2. We essentially just want to check all the sides of our rect1. So if the right side is greater than or equal to the left side of our rect2, then that means that we're currently overlapped. Same thing we're going to do for top and bottom. So if top is less than or equal to rect2.bottom. And then finally, lastly, we have our rect1.bottom needs to be greater than or equal to our rect2.top. This is going to check for a collision. So if we have a collision with any of our paddles, swap our X direction. Now if we come over here, comment this back in, we should hopefully see that if it hits our paddle, it's going to bounce to the other side of the screen. And as you can see, it's working pretty good. And if it hits our paddle again, it's going to bounce. But if it misses the paddle, so for example, if I miss, you can see that it goes through and it's going to score for the opponent. Now, the very last thing that we have left to do is to come into our styles here. You can see we have this hue variable. Well, we can actually change this in our JavaScript. If I go into the script.js, what I could do is I could say document element. That's going to select this root element here that has our hue variable inside of it. What I want to do is I want to get the computed style. So I could say get computed style, and I want to get the computed style. I want to get the property value for hue. And of course, I want to parse this as a float, just like that. I'm going to set this to a variable called hue. There we go. And then what I want to do is I want to take that hue value and set it. So we can say document.document element.style.set property. In our case, this is going to be our hue. And I want to just change our hue. So I'm going to take our hue, I'm going to add in our delta, and I'm going to multiply our delta by 0.01. So there we go. All we're doing is slowly changing our hue by this small amount every single time that our frame changes. And if we save, you can see over here that our color starts out as blue, and now it's kind of darker blue, a purpley color. And as time goes on a little bit longer, it's going to become a red color, then green and yellow and so on. This is just a cool way to be able to shift through all the different hues, give our game a little bit more visual appeal. Now, if you enjoyed this project, you're definitely going to love some of my other game clones, such as the Snake game or the Flappy Bird game. They're both linked over here. Highly recommend you check them out. And with that said, thank you very much for watching and have a good day.